Hi and welcome to a full-stack development coding session. Today we will build a complete OAuth2 secured web application and API backend. OAuth2 is the state-of-the-art authentication and authorization mechanism involving a client, identity provider and an OAuth2 secured API. We will set up a locally running Keycloak which we will use as an identity provider. We will also build an Angular web app which will redirect the user to a login page of the identity provider if the user is not already logged in. After the login, the web app can request an Acces token and use it to access a secured OAuth2 resource server. OAuth2 resource server is just another term for an OAuth secured API server. We will build that with Spring Boot and Spring Security, all with proper authorization so that only users with a specific role can access certain endpoints. So after building a complete end-to-end OAuth secured web platform, you will become a true full-stack master. Let us begin with Keycloak. So Keycloak is an open source identity provider capable of OAuth2. Eventually you will encounter it when working in an enterprise company. We will start Keycloak as a Docker container. Eventually you find pre-made Docker and Docker Compose files which you can copy-paste and just use. So that I will show and explain to you the most important parts of it. Don't forget that you can simply get my files from my GitHub link below the video. Starting with the Docker file, which is more or less a copy-paste from the official Keycloak guide. You notice that we set the environment variable kcdb to Postgres. That indicates Keycloak to use a Postgres database. Also, it creates a self-signed certificate for local development purpose. Now moving on to the Docker Compose YAML file. Keycloak needs a database to run, that's why we have a Postgres database here. The settings are straightforward, just some default username and password and create a database with the name Keycloak. For the Keycloak service, the previously shown Docker file is used to build a Docker image first. That Docker image is run using a bunch of environment variables. Here you can find settings such as the database URL and credentials, also the Keycloak admin console credentials, which we will use later. With this exposed port, we can access the Keycloak admin console. You notice that we mount a JSON file here. This one is used to import a full Realm configuration. This JSON file is pre-made by me and it contains user, client and user role configuration. You can reuse that or you can configure it manually. I am going to show you how to do that after we start Keycloak. In order to start the Postgres and the Keycloak, open a terminal where the Docker Compose file is located and then run the command docker compose up. The parameter --build enforces a Docker build with the Keycloak Docker file. After that, simply open the Keycloak admin console URL and log in with the credentials which you can find in the Docker Compose file. If you have imported my Realm configuration via the JSON file, you can find my created Realm in this dropdown. Here are a few important management areas, for example the clients. The client with the name My Web App Client was created by me. Also in the Realms role area you can find the role Fullstack Developer, which was also created by me. And in the users area you can find a user with the name TestUser1, which was also created by me. You notice that the user has assigned roles. One of them is my own created role. And in case you want to configure it yourself, just follow these instructions. At first create a new realm. Then create a new client. For that client you have to configure a bunch of URLs, such as for example valid redirect URLs. Because our client is a locally running Angular web app, we set everything to localhost 4200. Then create a new realm role. After that, create a new user. For that user, you have to specify a default password. And also assign the previously created realm role to that user. Congratulations, the Keycloak is up and running. Now let's move on to the Angular web app. We're gonna need an OAuth library which implements the login flow and fetches and refreshes the Acces tokens. For that I am using the library Angular OAuth2 OIDC. I have already shown this lib in other videos. It is quite good maintained and fully compatible with a variety of OAuth providers such as Keycloak. So after creating a fresh Angular project, we can add the lib via ng-add Angular OAuth2 OIDC. So having that lib installed, we need to bootstrap our application to initialize the OAuth service of that library. For that I am going to the main.ts file, and in there we see the bootstrap application function. This is responsible for bootstrapping the main app component, provided some application configurations. In that we must add a few things to the providers array. For once we need to provide the HTTP client. This one is needed by our OAuth2 service, and we are going to use it to send requests to our Spring Boot API server. Additionally, we need to provide the OAuth client. This one is from the OAuth library. Let us create an auth configuration object. In this object we add the issuer and the token endpoints. We can get these URLs from the Keycloak OpenID configuration URL. It returns a JSON config object containing our needed issuer and token endpoint, alongside with a bunch of other config values. Also in the auth config we add a redirect URL, which is the current browser location pointing to our Angular web app. After the user is logged in, this is the URL where the user is being redirected. Also it is important to add the client ID, which we have created in our Keycloak realm. Another important config parameter is the response type, which we set to code. There are two different flows, implicit flow and code flow. The implicit flow should not be used anymore as it is less secure. At last we can set the scope of our web app client. Here I just set some default ones. Let us create a function to initialize our OAuth service. The function input is of type OAuth service from the library. The function initializes the service asynchronously, so do it within a promise. At first we provide the recently created auth config object. After that we set up automatic silent token refresh. This is quite handy as the OAuth service automatically refresh Acces tokens before they expire. Then we call the method load discovery document and login. This is a shortcut method which makes the service to load the configuration JSON file from Keycloak and let the user log in if the user is not already logged in. And after that happened, we resolve the promise. So let us add another provider in the providers array. This provider will use the injection token app initializer. This one is used when you want to invoke some initialize functions when the web app is started. That is what we want to do, initialize the OAuth service right when the web app is started by the user. So add a factory method with the OAuth service as an input and call the initialize OAuth function. Declare the OAuth service as a dependency and it should work. We can actually now test if the user login is working. So let us open the Angular app and then we see that we are redirected to a Keycloak login page. In here we see the name of our realm. so we can log in with our recently created user. So let us analyze what the web app is doing in the browser's Developer Tools Network Monitor. For one, we see that our web app is calling the OpenID configuration endpoint of the Keycloak. This is part of the OpenID Connect protocol to get a config, so the clients can configure themselves using this config JSON. If you wait long enough, you see that the web app is calling the token endpoint of Keycloak. This endpoint returns alongside with some other things the Acces token. Keycloak returns tokens as JSON Web Tokens. The abbreviation of it is JWT. You can copy the Acces token and inspect it on the page jwt.io. In here you can see the payload of the JSON Web Token. The items here are called claims. For example, you can find that the user has realm roles assigned. Along them is our custom role, Fullstack Developer. Also, you can find the name and the email of the user. We will extract this information later in our Spring Boot API server. Before we continue with the Spring Boot service, let us go back to the app component and add some functionality. I am going to add a button for the Logout functionality. In the app component class, let us inject the OAuth service. The logout is very straightforward. Just call the logout function of the service and the user is logged out. Let us quickly verify that it actually works. Open the Angular web app, log in if necessary, and click on the logout button. After the click, the user is redirected to the login page again. The last missing piece is an OAuth secured API. Let us create a new Spring Boot app with the Spring Initializer. We have to add a few dependencies. The first dependency is Spring Web, which enables us to create REST API endpoints with REST controllers. The second one is Spring Security. Obviously, we want to secure our API endpoints with OAuth access tokens. We will configure a security filter chain to enforce security rules. The third dependency is OAuth2 resource server. Our Spring Boot app acts as a OAuth2 resource server. Such a server verifies the access token against the token issuer, the Keycloak. After we open the fresh project in an IDE, we create a custom JWT class, which extends from JWT authentication token. This class will be a container for all relevant token data, which we will extract from the JSON Web Token. This token will be created by converting a generic JWT class into our custom JWT class. For that, let us create a new class which implements the Spring Converter interface. The input of the converter is a generic JWT class, and the output is our custom JWT class. We have to override the convert method and implement the conversion logic. For the time being, let us create an empty list of granted authorities. We will take care of that later. Then let us extract the first and the last name of the user from the generic JSON Web Token class. and set those things to our custom JWT object. Now it is time to configure the security filter chain. Create a new class for security config. Here we have to set the configuration annotation, so Spring recognizes it as a config class. Also add the enable web security config annotation to enable security chain. Create a new bean function which returns a security filter chain. The input of the function is a HTTP security object. In here we define the chain. At first enable cross-origin resource sharing with default settings. This is important so the CORS pre-flight request of the browser is not rejected by the security chain. Then configure the Authorize HTTP request. All incoming requests must be authorized. Then configure the OAuth2 resource server step. In here we specify to use our custom JSON Web Token converter. In order for the token verification to work, we must go into the application properties file and configure a JSON Web Token issuer, which is in our case the Keycloak. Remember that you can find the issuer URL in the OpenID configuration file from Keycloak. At last we have to create a controller class. The REST controller is the entry point for our API. We have to enable CORS for our Angular web app, so set the correct allowed origin, allowed headers and allowed method. Let us define a record which will be used as the return type of the API. It contains a message string. Let us create a function with a get mapping hello. It returns the message record. In this function, we can access the security context holder to get the authentication. We can cast it to our custom JSON Web Token class, because we know that our custom JSON Web Token converter is being used in the security filter chain. Let us prepare a message which we will return, containing the first and the last name of the user. The API is now secured and ready to be used. Finally, start the Spring Boot service and then go back to the Angular web app to implement the API call. In the app component, let us inject the HTTP client. After that, add a button to trigger the API call. When the button is pressed, we dispatch a HTTP GET request and expect a JSON response with a message text. The URL is pointing to our locally running Spring Boot app. Also, we have to add the Acces token from the OAuth service as a bearer token in the HTTP authorization header. After receiving the result, we simply display the text in a HTML division. So now we can actually do an end-to-end OAuth test. Simply open the Angular web app and log in if required. And then press the button to call the Hello API endpoint and let us see if it actually works. There is one final detail left to take care of. How do we actually authorize the Hello endpoint to be used only by users which have a specific user role? We remember that the JSON Web Token contains assigned user realm roles. Let us go to the custom JSON Web Token converter and extract granted authorities. In the generic JSON Web Token, we access the realm Acces. And in there we access the property rows. Then we iterate all rows and add them into the list of granted authorities with the prefix role underscore. Let us go to the security config class and add the annotation enable method security. With that, we can add a certain annotation to our hello endpoint function. go to the Hello controller class and add the annotation pre-authorized to the Hello function. In there we can use the Spring expression language and say has authority role _ fullstack developer. This annotation makes sure that only users which have the extracted authority from the JSON Web Token can access this endpoint. We can test if we are still able to call this endpoint with our user, so log in again and let's push the button to get the hello text. Now let us do the negative case and remove the role from the user in the Keycloak admin console. So when we log in again and press the button, we see in the browser network monitor that our request is rejected with the response code 403, forbidden. Now you have learned how to secure and authorize API endpoints using OAuth2 and JSON Web Tokens. Congratulations, you have become a true full stack master. Goodbye and have a nice day.